Have you seen that video before? Are you amazed? Wanna recreate by yourself? Good. Welcome to the tutorial. In this video you're gonna learn the basics of the editable mesh, so in the future you will become the master of meshes. Look at this beauty. Isn't that disgusting and beautiful at the same time? Okay, congratulations, you converted a Freddy Fazbear to a sphere. But if I press run, you see the sinus wave goes on a diagonal. Oh yes, look at this, look at this, look at this, yes! Extract the sphere, perfect. Okay, where do we start? First let's talk about limitations. The first one is the editable mesh texturing sucks. Hopefully Roblox will fix that. Second one is you're not able to apply the collision changes yet. You have to wait until the Roblox will enable that function in your Roblox Studio. Also about the scale and vertex color, they are not working at the time and you almost have no control of the properties of the editable mesh. Next one, you are able to create only 60,000 vertices. Next one, you cannot edit the model with skin in detail. By the way, you have no way to access the image texture of the editable mesh, only its UV. You cannot update the meshes with parallel Lua and the release date is not known yet. So how to create an editable mesh? First way to create mesh is just simply saying instance.new editable mesh. But it will be empty. If you want to save the precious vertices of the Amogus you found recently, there is an asset service for this. Then you say asset service create editable mesh from part async. And you put the mesh part in it. Okay, let's really quick switch to live. And we're going to the Roblox Studio. Let's talk about the vertices, how to edit the vertices. I will go to the toolbox and I will search for the sphere. Sphere, I will take this one, that's too small. I will take this one. This is high poly sphere. I will take the script of Amogus here. What it basically does, it creates an editable mesh from the object we have here. In our case, it will be the sphere. Okay, we will move our Among Us here. Just be there. So now, if we go into script, we want to edit the vertices of the sphere. First thing, how to get the vertices? We're going to write local vertices equals editable mesh get vertices. What that actually does, it will return us the array of vertices. Not the vertices, but their IDs. We're gonna randomize the positions of the vertices. By the way, all positions of the vertices are in local space, so don't forget about this. What we're gonna do now, we're gonna store the positions of the vertices. We'll write local vertices positions equal this vertex ID in vertices do. We're gonna save the position of the vertex and write it into the table by the index of the vertex ID. So we're gonna write local position equals editable mesh get position. So we have to put the vertex ID to get the position of the vertex. Again, this position will be in local space, so encounter on that. So we got the position and it comes from the center of the mesh. Then we're gonna write vertices position vertex ID equals position. So we saved the positions of the vertices. First, don't create another loop. What we're gonna do is we're gonna randomize the positions of the vertices. Let's do it simple first. Editable mesh set position. So that's how you set the position of the vertex. Then you write vertex ID and let's do our position random.new next unit vector. Now, if I press run, you see that all our vertices collapsed into one sphere, like one part large. And then we're gonna animate them right now. So what we're gonna do for that? We saved the positions of the vertices and we're gonna create a while loop. So we're gonna do while true do. We don't forget in the task.wait, and task wait has a minimal delay of 1 frame. So it's basically 60 frames per second. So what we're gonna do? We're gonna loop through all vertices. We're gonna copy that loop. We're gonna take the vertex ID, put it here, and we're gonna put the position, and we're gonna change the array vertices positions. Okay, we created a loop. Now what we're gonna do? We don't need to save the position anymore. We're gonna say editable mesh column set position vertex ID, and let's change our position of the vertex. So let's create new position and it will be position.unit multiplied by mass.noise. So we're gonna create a noise on our sphere and we're gonna put 3 variables: position.x divided by 100, then position.y divided by 100, and position.z divided by 100. And at the start we're gonna add the previous position plus like this. So right now there will be no animation, only one still frame, and we're gonna put set position to the new position. And if we press run, you see, no, you don't see. I think we put the thing too high, so we're gonna do like this. And now As you see, our sphere became not a sphere, but something like potato. How we can animate this? We're gonna offset our position. So we're gonna put the white spaces here, 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 and here. And what we're gonna do, we're gonna add the os.clock. So we're gonna add the time to this. And here os.clock. We cannot put, unfortunately, the vector into the mass.noise. It would be way simpler than that. Now, if we press run, you will see our sphere is animated. You see also that line. I will show that on the light. I will turn it like this. That line is just topology of the mesh. So if the mesh has proper topology, you will not encounter this shit. That's how you put the position of the vertex in place. So as well, right now, there's a lot of options for vertices. Let me write all of them. So for each set function from here, there's analog with get. We have set position, so we have editable mesh get position. For each of that function, there's a get function as well. And what we can do, we can get adjacent vertices. That means we get the vertices connected to that vertex by triangle. So next one, set position, just set the position of the vertex. Vertex color, it doesn't work yet. Roblox need to fix that. Set vertex normal. I think that's for calculations of the triangle normal. We shall change that thing as well. So set UV, it will set the position of the vertex on the UV map. If you're 3D modeler, you know that, or you just have some experience with 3D modeling. If you don't know, just look in the internet. So, and set vertex color alpha. That thing doesn't work as well, like set vertex color. Just for now, I think Roblox will fix it. The release date of this editable mesh, editable image is somewhere in 2024. It's not early, it's not late. Maybe it's late, maybe it's middle, but we have to see. Okay, now let's try something else. How we can test new things? By trying to break it. How we will do that? We have set vertex normal, and what we're gonna do, we're gonna put the vertex ID, and we're gonna generate a random unit vector. So we're gonna say random.new next unit vector. So if I press run, you see, more weird shit happens. Inside, nothing changes, but what changes is the texture. And as you see, reflections. My FPS is not very good right now, and I think that's because of the random. Random is pretty heavy function. And we're gonna increase our animation, like put the magnitude to the new position. Like position.unit multiplied by noise and multiplied by 5. That means that the position unit will be from range -5 to 5. So if we press run, we're gonna see something interesting. Look at this beauty. Isn't that disgusting and beautiful at the same time? It's like something gonna burst from it. This sphere gonna explode. Okay, now we experimented with vertices. You know how to put the position of the vertex. You know how to change the parameters of the vertices. You know how to add the editable mesh. So what we're gonna do now, we're gonna create a new editable mesh. So we don't use asset service for this instance. We're gonna say instance.new editable mesh. Yeah, and right now I'm gonna show you how to create an empty mesh and just do something with it. So we're gonna go to the workspace, we're gonna create a mesh part. We're gonna set the size of the part like 1 by 1 by 1. Okay, now we're gonna take the script from here. Now we have a part, let's anchor it. So how do you create triangles and do something with them? So we have our script, let's delete this loop, let's delete the vertices because we don't have the vertices right now. So we're gonna create a triangle. For this we need 3 vertices. So let's create a vertex 1 equals some random position will be random.new 1 2 1. Let's create another vertex and another vertex. Here 3 3 and here 2 1 0. Let's name them like vertex 1, vertex 2 and vertex 3. Let us create the triangle right now. Okay, and now how do we create a triangle? We write editable mesh add triangle. Add triangle. For this we need 3 vertices. Yeah, we need to create these vertices like we did before. We write editable mesh add vertex, and we're gonna put this vector inside of this function. So we're gonna copy this one, put it here, put it here, take this vector and take this vector. What it's gonna do, it's gonna create a vertex with a position in this vector, and it's going to return us a number. That number is the ID of the vertex, and we know what to do with that. So we're gonna write editable mesh column add triangle. So you see it requires 3 vertices, their IDs. So we write add triangle vertex 1, vertex 2 and vertex 3 like this, and we're gonna look for our mesh part here. So as you see, here's the triangle we created. The normal of the triangle I think is based on the order of the vertices. So for example, let me try to do something. Let me create them in another order. Yeah, so the normal of the triangle is based on the order of the vertices. So if I create the triangle with vertex 3 2 1 and I run this, the triangle will appear on top. But if I write vertex 1 2 3 and I'm gonna run this, let me find the triangle. So as you see, the triangle is on the bottom side. If you don't want to guess where the triangle will point, you can just select the mesh part and make it double-sided, so the triangle will appear from the both sides. And by knowing this, let's practice a little bit. Let's create a flat plane with vertices. So what we're gonna do, we're gonna delete these vertices. We're gonna delete these vertices as well. We're gonna put the two variables, local width equals 100 and local height equals 100. The maximum value for this will be like 140, as I remember. So now, what we're gonna do? We're gonna create a table, local vertices, like before, and we're gonna create the vertices right now. We're gonna loop for y equals from 1 to height, do. For x equals 1 to width, do. So what we're gonna do now, for each y, we're gonna create a table called row. We're gonna create a position for the vertex. Let's call it vertex position. And we're gonna say vector3.new. We're gonna put x and z value. So we're gonna say x minus 1, 0, y minus 1. We're gonna create a plane from the starting point. We need to write this minus 1 to create from start from this little mesh part. It's gonna go from the middle of that mesh part to somewhere else, somewhere here. As you see, we add in the x and z value. So we have the vertex position. We're gonna say EditableMesh, add vertex, and we're gonna put the vertex position. We're gonna get a vertex ID. So let's write this. Vertex ID equals EditableMesh, add vertex position. And now we need to save the vertex ID inside of the row. We're gonna save that vertex ID by the x value. So we say row x equals vertex ID. We created the vertex, and now at the end of the while loop, we're gonna append this row to the vertices. We're gonna say vertices y equals row. So we saved the vertex and we saved the rows. Now we have the plane, but if I press run, as you see, even if I select this mesh part and make it double-sided, you see nothing because we need triangles. So what we're gonna do now, we're gonna copy this loop again. We're gonna say here to height minus 1 and here to width minus 1. Then we're gonna remove that row, we're gonna remove that vertices, and we're gonna remove that thing. We need to have like 4 vertices to create a square, but we cannot create a square. So we will create 2 triangles. So what we're doing now, we're going to define vertex 1, local vertex 1 equals, that will be vertices, y x. We're gonna do this for all 4 vertices, so local vertex 2 equals vertices y plus 1 x. Local vertex 3 equals vertices y x plus 1. So what we're doing here, we are taking the original vertex, vertex 1, and we take the neighboring vertices. We cannot use adjacent vertices because we don't have triangles yet. And now, to create a square, we need first vertex, local vertex 4. And let's say to create a second triangle. Yeah. And the vertex 4 will be vertices y plus 1 and x plus 1. So that's not a neighbor, but a far neighbor. And now we're going to create 2 triangles. Local triangle 1 equals EditableMesh, add triangle. We're gonna use vertex 1, vertex 2, vertex 3, vertex 1, vertex 2, and vertex 3. And then we need to create second triangle. We're saying local triangle equals EditableMesh, add triangle. And we need 3 vertices. We will not use vertex 1, but we will use vertex 4 instead. And we're gonna change the direction. Vertex 3, vertex 4 instead of vertex 1, and vertex 2. Okay, we press run. We see we created our plane, but I messed up a little bit with indexes. Let's try to swap the vertices. We're gonna need to swap vertex 2 and vertex 3. Now we press run, we got a plane. Yeah, we cannot see something from the bottom because our mesh is not double-sided. If you want to do this, you go into properties and enable double-sided. Now we can see the mesh from the bottom, and let's create some interesting things with that. Let's create a simple way. We're going to use just a normal sinus. In this case, we're going to use run service. So game colon get service run service. It is server, so we use the heartbeat, and we're going to use connect function. We got it at time, but we not using that yet. Now let's change something. Let's go to the first loop, and instead of putting just the vertex ID, we're going to put that in the table, and we're going to put the vertex position at the second index. So now we go to second loop. We're going to say that each vertex is index 1 now, and let's go in the run service. We're going to copy that loop again. We're going to delete this. We're going to delete this. We're going to delete this. And let's calculate the positions for each vertex. And let's convert it in a simple way. We're going to take the position of the vertex. So local vertex ID. Again, we extract the values. Equals vertices y x and 1. That will be the vertex ID. We copy that, we put it here. We use the index 2 and we're going to say that that is the vertex position. Good, we have the vertex position and we have the vertex ID. Now we're going to change the vertex position by its local position. We need time, local current time, to animate this equals os.clock. Then we're going to calculate the new position of the vertex. We're going to say local new position equals vertex position plus vector3.new 0, 1, 0. So we're going to use only y-axis multiplied by mass.sinus of the current time. Right now, let's make it without the position. And if we press run, we're going to see nothing. Why? Yeah, we have to apply the position. So we're going to EditableMesh, set position, vertex ID, and new position. If we press run right now, we're going to see that our plane is going up and down, but we need that for each vertex. To change the position for individual vertex, we're going to use the coordinates of that vertex. So we're going into our script and we're going just to put the x value here, and we're going to offset the time. So plus vertex position dot x. Let's say that we export this as a vector3 and here that we export as a number. Let's do here the same. We make this to ensure that we're using vector and number. Let's clean this and let's look at the result. So now we see a nice sinus wave. We can use this already for normal waves or what you can imagine. But don't forget the limitation. You cannot create more than 20,000 triangles and you cannot create more than 60,000 vertices. So you have to duplicate this. That's up to you. So if we look at our frames, let's pause this and we're going to do the detailed. Let's look at our script. So our script with calculations is taking 7 milliseconds. So if you make an ocean, be careful with it. Just try to create some limited paths, because if I duplicate this part a couple times and I press run, you already see like lagging. If I press Ctrl F6, you see that our frame rates are not good. And by the way, I have a good processor. Let's look at our script. All calls are deferred. So we're changing the 10,000 vertices for each plane. And because each script does the same thing, we're getting a long wait time. I think if you will manage to get like 60,000 vertices, that will not be a problem only for one mesh, because only one script calls it. But if you have like a couple of them, that will be the problem. Yeah, or you can just put everything in one script. Okay, let's delete these planes. So we got a nice sinus wave right here. Let's do that the sinus wave goes on the diagonal. We're going to our script and we're going to say vertex position.z, because we don't use y. Y is 0. So if I press run, you see the sinus wave goes on a diagonal. Let's go into our script and let's change something. So as you see here, we put the position of each vertex with offset of 1. Let's lower this value. Let's create another variable called local offset and let's write something like 0.1. We copy that offset and we press multiply by offset. So as you see, our plane became much more smaller here. So if I open view and I open wireframe rendering, as you see here, every hour triangle. So let's apply the noise to that thing instead of the normal sinus wave. Let's delete the thing. Right, then we're going to say mass.noise. We're going to put the position vertex position.x, vertex position.y, and vertex position.z. Let's multiply this by 0.1 just to scale the noise a little bit. And let's offset this by the time. Let's go here, press enter, enter, and enter, and here enter as well. We're going to add the current time. Okay, and now if we press run, we got an error because we cannot add the number to the vector. What we can do, we're going to say vector3.new 0, 1, 0. So that's a vertical vector. We press run, we see our noise. So let's scale it a little bit. So instead of offset 0.1, we're going to put 1. And now you see a nice noise here. Let me open wireframe rendering. So now you see noise. Yeah, my GPU likes it as well. And let's do some weird shit. So we're going to multiply this mass.noise. No, not multiply. To the power of 2 minus 2. Let's run it. Oh yes, ladies and gentlemen. That's what we call a weird cheat. Perfectly balanced. Okay, now we have a little plane animation. Nice plane animation with waves. Maybe if you increase that mass.noise by some amplitude of 5, for example, and I run this, now you see the difference. Now we will do another weird shit for this. So let's go to this Amogus. Let's open the script. Delete this previous thing. So let's copy the start of it. Now we take our Amogus asset service, create EditableMesh from part async object. So we created our Amogus. Let's project him on a sphere. Now we need to get the vertices of the Amogus. We say local vertices equals EditableMesh get vertices. Now we're going to save the positions. Vertices positions equals table again. and we're going to loop through each vertex. We're going to get the position and save it to the table. So what we need now, I'm going to borrow this function, this little map function. What it actually does, it takes a value, you specify the minimal and maximal of that value, and it will output another value with different output minimal and output maximal. You can also clamp the value at the end as well. So what we're going to do now, we're going to twin positions of the vertices, but we will not use twin service because twin service requires an object to have a property, but we have only IDs. So let's create a function. Let's call it animate vertex. So what we're going to do, we're going to take current time. We're going to pass this from the loop. Then we're going to put animation time. We're going to put the vertex ID. Let's put the desired position. Now let's do a simple loop. So now what we're going to do, we're going to copy that loop. We're going to loop through all vertices. And then we're going to call the function animate vertex. Our desired position will be on the sphere. We're going to create a new position equals vertex position.unit. And let's do the radius of 15. So let's look at the result. We forgot to anchor it. Let's anchor it and look at the result once again. Oh yes. As you see, a perfect sphere mongoose. Let's do that with something else. Let's go to the toolbox, meshes, Freddy. I like Freddy. Let's take this gigantic Freddy fuzzbar and put the script here. Run. Okay, congratulations, you converted a Freddy fuzzbar to a sphere. By the way, let's convert something else into sphere. Toilet. Why is it so? Why is it like this? I freaking didn't expect that. Oh yes, that's perfect. Okay, let's do something more interesting with that. Let's wrap the Freddy around the toilet. We have a Freddy, we have a toilet. So I'm going to take the script inside of the Freddy fuzzbar. Now we will calculate the table of the desired positions. Then we're going to press enter, copy the vertex toilet local position. We're going to do EditableMesh toilet, find closest vertex, vertex toilet local position. Then we convert to the Freddy local position, and we're going to save that to the desired position. Desired positions, vertex ID equals Freddy local position. Okay, now we don't need that thing. Now if I press run, look at this, look at this. Oh my god. What? No, we need to put the toilet inside of Freddy to see the better effect. Okay, anchor the Freddy, run. Going to rotate it a little bit, like this. Oh yes, perfect. The toilet Freddy. Let's move our toilet and look at the Freddy. Oh yes, perfect, perfect. We can convert Freddy to everything. Let's convert Freddy to the Among Us. We're going to take our Among Us and put the Among Us inside of the Freddy. Okay, now we can extract the Among Us. We got the Freddy Among Us. Still doesn't look okay. Okay, and let's do the final thing. Let's convert Among Us to the sphere, or sphere to Among Us. Oh yes. Oh yes, look at this. Look at this. Look at this. Oh yes. Extract the sphere. Perfect. Okay, thanks for watching. If you liked the tutorial, you can like this video as well. If you didn't like this tutorial, you can dislike it, of course. So the next tutorial will be on the editable image, and I promise to prepare some fun stuff as well, like here. Hopefully that helped you. Bye.